And as David said, I'd like to keep the session interactive. So please feel free to speak up at any time. You know, if there's some background noise and you can mute yourself, that'd be great. But, you know, again, please feel free to speak up and ask questions or use the app for questions. Ward will be monitoring those.
Sorry, Brian. I think we've unmuted everyone now, so maybe we can mute everyone, but allow themselves to unmute themselves.
Okay, I have set that so allow participants to unmute themselves. Sorry for the interruption, Brian. Go right ahead.
Okay, so yes, we'll try to be less interactive than that, but still be interactive. So again, please feel free to speak up or use the app to ask any questions. Again, Ward will be monitoring those. As David said, my name is Brian Bialecki. I work for the American College of Radiology as the Director of IT Standards and Interoperability, and I'm going to be talking about imaging references in observations and diagnostic reports. And I do not have anything to disclose, not saying that I'm not open to disclosures in the future. So if you would like to offer something, I'd be more than happy to take that up. But I'd like to start with what is an annotation and kind of what I'm going to be talking about and the kinds of things that I've been trying to express that I've been having a little bit of issue with the way that FHIR is set up today. So when I'm talking about annotations, I'm talking about physical marks on an image that today in radiology are either captured as a secondary capture or screenshot, a CAD structured report, as GSPS objects, or they are proprietary things that are put into vendors' databases. These can also be visual findings. So an annotation could be that, you know, what the breast density is for the mammogram, or that a chest x-ray is normal. Or these could be a mix of things. Things like there is a fracture and also the radiologist puts an arrow as to where this particular thing is. And these items could be added by AI or added by the clinician themselves. So obviously this project was done looking at, you know, talking about annotations and how these could be described using FHIR. It was done with some work with Daniel Rubin at Stanford and his AIM models. We've used the Sim Hackathon Committee's FHIR server to place some of these onto the server. And again, I'd like to kind of talk a little bit how I worked on expressing these annotations using FHIR and try to get some feedback on the approach to this. Okay, so a traditional radiology report, you know, we'll get an order. The order is asked to rule out pneumothorax. The image is captured and it's reviewed by the radiologist. The radiologist says negative. This is a very straightforward way that things are annotated, but obviously in the radiology world, these are narrative reports and the structure is very limited. Without knowing the context of what the order was for, negative for a chest x-ray could be assumed normal or be negative for exactly what was being asked. Also, you could get a negative but. So I have a chest x-ray to rule out pneumothorax just like before. In this particular case, there is no pneumothorax, but the radiologist finds a bunch of items. So as they start describing these particular findings, they're dropping arrows onto the screen. Well, in a narrative report, you know, it's very good. They've described all the things that they need to be telling me. But if I am a clinician who needs to, you know, follow a recommendation for a biopsy, I'm not exactly sure which arrow pointed to the place where the biopsy was supposed to be done, and therefore it's a little discordant if I'm reading the text as to which arrow describes which item. And so this is kind of where we wanted to go a little bit further. So today in radiology, there is a growing bunch of work on use cases where a particular finding has a descriptive way to decide how I'm going to annotate a particular finding. And then all of the items that I'm supposed to be reviewing prior to coming up with that particular finding, and then the types of outputs that should go along with describing that particular finding. This was done initially by Daniel Rubin when he worked on AIM, and now the ACR Data Science Institute has taken and started creating use cases where these are expert panels that are going through hundreds of findings, explaining exactly what should be looked at and how the output should be described. And then the ACR and RSNA have built a group of common data elements that go along with these particular findings and have very specific values that go with each one. All right, so now trying to bring that over to FHIR, and here's kind of what was done. So if I have a mammal report today, and this one seems very straightforward. Again, I have an image, the radiologist is reviewing this image, and I would have an observation where I say that I found a mass, here is the size. I can describe the image in which this is on, but I can't describe the exact location of the image. If I pull up this image today using FHIR, I could look at the markup if it is saved where I'm getting the image from and correlated to it. And there's one markup on this particular image that seems very straightforward. I'd be able to find that. But if there was no markup, I might be looking in this particular area. Or if there were two arrows on the image, one to this area and one to this area, I'd want to be sure, which one I'm specifically talking about. And that's where we found that there was a gap in what had happened. So after some work, we kind of came up with this particular option. I've worked with the Imaging Integration Group and DICOM Working Group 20 to come up with a way to do this. So in observation, we say that it has been derived from a document reference. The document reference can actually get me down to that particular image, but it can't actually describe on that image where those endpoints are. So then we created an extension, and that extension now allows me to tell which pixel locations this bi-ruler is on and the endpoints of those particular items. So I kind of built some resources out, and I'll go through those, but I have them listed in the slide so that they could be seen after the session. So let me actually go to some of the stuff. Let me get out of this and go over to, so in DICOM, again, I had talked about AIM, the annotation image markup. All of the annotation image markup items were mapped to the DICOM standard, and they are listed here. So this is kind of how all of the particular markups that I have built for this as examples were done. After we created this particular extension, we actually added it as part of the breast radiology reporting ballot. So their current ballot, the IG, is posted. We added this so that, again, when I'm looking at a particular mammogram and I have a finding, I can not only describe the finding itself, like that is a mass, but I can go through and describe the exact endpoints that this has associated with it. So we can come up with the, UID for the study, the instance that it's particularly derived from, and all of this again is in the current breast radiology reporting IG. All right. And if I look here, we actually kind of list out the individual SOP class, the frame, a tracking UID if I want to track a particular mass over multiple studies. And then the region itself allows me to tell, you know, what type. Is it a polyline? Is it a biruler? And then what the coordinates are for that. So I can map it directly onto the image. Okay, so a little bit more about this. This is from the imaging integration Confluence page. We initially started off, if I went back, we were going to propose an entire image resource, imaging reference resource for this particular project. But after, you know, some, you know, discussions with other groups, it came about that we would create this extension. And again, the extension and document reference. There were two ways to potentially do this. One was a use of extension to content. Because in content, the URL would actually describe the actual image study series and instance. That was initially thought that that would be enough, and then I could just add the particular coordinates to that. The issue becomes that I saw with this one is that DICOM web point URL can change over time, and now it would become difficult to actually find the image. It may not exist at the particular URL in the future. And so specifically calling out, and you'd also have to parse this specifically to find what you were looking for. So the second option was to create an extension to content. And this is the one that I used throughout this project and all of the examples. So in the imaging context, we actually call out the study series and instance specifically, the particular frame numbers, tracking UIDs, and list regions and their particular coordinates. Again, these regions are defined back in the DICOM standard. All of the initial examples that we built, we placed on GitHub. Again, there's links here in GitHub. So all of the, you know, I actually went out and built the diagnostic report that we thought would kind of go with these. We initially had the images marked up. So the images themselves exist here. They were marked up using AIM and the ACR DSI pneumothorax use case. We marked them up with AIM, and then we represented those as diagnostic reports in FHIR. All the observations are different clinical data elements for the pneumothorax use case. And then as we had markups drawn to describe pieces like pleural separation, we actually reference those through observations and the document reference extension. So again, all of the examples, all of the imaging, everything, the DICOM files, the AIM files, the AIM converted to DICOM SR, all exist in this GitHub repository. And then what we did is we actually took all of this and we loaded it up on the Sim Hackathon FHIR server so that it exists here today. The structure definitions that were put in for the extension, and then we loaded the example reports. So there are 2 reports that were loaded. and all of the pieces. Before I kind of go through and actually show you some of the examples, I'd like to open it up if anybody has any questions at this point.
So let me start by one question from the chat. There's a question by Damien Jones. Are these extensions specific to radiology images, or could they transfer the whole slide images and annotations?
So these can definitely transfer to whole slide imaging. The way that they were defined was with the DICOM standard, at least as a backbone for this. And today, these same annotations for whole slide imaging are part of another DICOM working group, but we're making sure that they were not specifically tied directly to radiology only images, but could also be transferred to pathology images or any other context. So any additional questions?
And Damien, please also feel free to unmute and follow up.
Hi, Brian. It's Elliot Silver.
Hi, Elliot. How you doing?
I'm doing well. So somewhat tied into that, do these handle multi-frame as well?
Yes. So, and again, didn't do that in the examples, but again, the extension gives specific frame numbers. So I can pick one or more frames when I do this.
Okay. So
And we actually did that. Oh, sorry. Also, if you kind of look, we were looking at that when we were thinking about breast tomo and how these would line up on specific tomo slices. So
Right.
looking through the breast radiology IG is another place to kind of see how we did that. Again, still no examples built on frame number yet, but frame number was allowed for.
I'm a little concerned with the region because it seems to me that you can specify in this extension, you said polylines and things like that.
Yes.
You can also have a presentation state in the DICOM that can specify polylines. There's nothing here to synchronize those, and you could have an arrow that the radiologist sees on their viewer, on the radiology viewer, that points to one thing, and an arrow that the referring physician sees on their viewer that points to something else.
Correct, but, and I can explain this, a presentation state would be its own series, and it's not, I would not be specifying the coordinates in the presentation state. The presentation state would exist in the series, and therefore I wouldn't need to use the document reference extension at that point when I point to the observation. I could just use the document reference itself to point to the individual series or instance that the GSPS object exists in. This would work the same if I used a CAD SR. This is only if I want to specifically call out a particular markup is what this extension is for. Those use cases already worked. So if I wanted to build a DICOM SR and bring that up, that was available. Or if I created a GSPS, I could point to those directly without actually specifying the coordinates inside of them.
So, but the GSPS may contain more than a single image. It may also contain multiple markers.
Yes, but I could call, so there is, today I can call that without the extension. I only need the extension if I want to place coordinates on a particular image. And now obviously I wouldn't be able to reference a very specific observation if I was calling a GSPS object, which I think kind of gets into some of the issue. if I wanted to point to a specific arrow, I wouldn't save my initial finding as a GSPS. But if I saved the GSPS object, I could point to it directly, but I'd have, you know, kind of that initial look like, you know, this could be my GSPS or something like this.
On what they sell.
Right.
But they are going to.
So I wonder, I don't recall the details of GSPS right now. Sorry for the background noise. I don't recall the details of GSPS right now. But does it have a observation UID for each line or something equivalent?
So basically GSPS just so it would give me, here's how, you know, put this particular series on the screen, go to the fourth image, set the window level to this, draw this particular line on it, type this text over it. It basically sets how the screen was at that particular time.
Right. So what I was wondering is if the draw this particular line on it has a unique ID, which would then allow us to reference that in this extension rather than saying a particular region.
And I do understand that, but from what I have found from GSPS, I wouldn't be able to do that. That's why we wanted to go down and be much more specific and point to a particular line. You know, I didn't want to use a CAD SR where it's basically an overlay to an image, or a secondary capture image where, you know, I just have basically a screenshot. Because there could be multiple items on it, and it's very difficult to figure out. And I think that's part of what's gone on with, you know, radiology reporting in general. Not to beat up my own here, but and I think that's where AIM was really starting to go. Is AIM is calling out every time I drop a point, I'm going to describe why I dropped it on the screen. But what AIM missed was, okay, I could have, you know, a normal chest x-ray is actually an observation. Well, if I didn't draw anything, I didn't have an annotation image markup. And that's being corrected now. But in this particular case, what we're saying is I should be specifying every single line so that I could particularly call the individual line, and I'm not looking, you know, from that DICOM lens of here's everything that was on the screen, and then I'm going to tell you what I was describing and hope the radiologist labeled them correctly. We want to label them with every time I draw a line, I create an observation, and that observation and that line are linked. So I know specifically what they were talking about, and it doesn't get gray, which I think some of the DICOM objects do.
Brian, can I interrupt with two more questions that came in?
Sure.
So one is quite similar to the question that came in before, I think. Does this also work for non-DICOM images such as wound images? I think you might have covered this already a bit.
So, you know, non-DICOM images today, you know, I don't have a specific, I wasn't looking at it from that particular perspective. Mm-hmm. Again, I was looking at, yes, it will work for, you know, pathology, but specifically in non-DICOM, I can take a look at that for the future.
Yeah, so this is Axel Biernat. And again, Axel, feel free to unmute yourself and join in. So you're saying this is something you weren't focusing on right now, but might be interesting. I think especially if you have other people who are willing to pursue this use case and help you with it. Correct,
because obviously items like, you know, I would want to add this or, you know, make it available for something like a dermatology photo would be, you know, extremely helpful. But today, you know, just that isn't something that I was able to kind of track down this way.
Yeah. Yeah, it's important to have real life use cases steering you
Yes.
there. And then there's another from Rajiv Pillai. Does it capture image / annotations references to timeline or similar studies on the same patient?
So yes, because so a couple of things. Because I'm looking at a particular study instance UID, I can then line that up with the patient record. But also having things like tracking UIDs so that I can basically have that UID assigned to a particular mass inside of this would allow me to track that particular mass over time. So for, say, a recyst measurement, I can assign a UID to a particular mass, and actually some of the breast items, they're now, instead of using the clips, they're actually RFID chips that they're able to have UIDs assigned to.
Okay, very good. So this will help tracking
Yes,
patients
this
and
will
specific
handle
entities
tracking
over time.
patients. Again, obviously because the study UID aligns to a session number, which aligns to a particular patient, would all be able to be tracked over time.
Yeah, yeah, makes sense. So Brian, I think you had this session specifically because you're looking for feedback and input. Are there specific points you want feedback on? And maybe can you comment on what the status is? Is this like a draft that will be balloted at some point, or is it?
So this is, you know, a draft that's currently part. I mean, obviously if people have feedback today, they could use the breast radiology reporting ballot to start on this extension. You know, some of the items, the way that we had to list the coordinate strings inside the system, you know, I'd like to be able to go a little bit further with this today. You know, right now I have 2D and 3D coordinates. I'd like to get into volumes where I could specify, you know, there are a lot more things that I can provide with DICOM that I can provide here. I mean, I was happy to, you know, list a line or a bi-ruler or an arrow. But if I want to get into specifying an entire volume, I'm not sure that I can specifically do that, or if I'm going to have to create, you know, additional DICOM series and just point to those particular series, or if anybody has ways that they've seen coordinates listed in other resources that I may be able to use in the future when I'm talking about, you know, a volume that spans, you know, hundreds of instances, and it's just subsets of pixel data inside of it that may, you know, if I segment out a liver and I want to talk about the liver, how, you know, right now, the way that I've done this is I can specify, you know, an arrow or a bi-ruler or a ruler, but I'd like to go further. Not sure that, you know, is this the way to go? If I want to go that much further, you know, is there something else people have seen that they think might be more useful?
Yeah, some prior art. Great. So we have, I think, about 10 minutes left. So we should definitely ask people to turn on their cameras, unmute, and jump in at any point.
Sure. And again, I can show like these do exist today here on, if I go into the Sim Hackathon server, these final two reports, this sample 1 and 2 are where they exist. So we built these out, you know, we called these particular observations in here, the studies exist, you know, if anybody were looking to do this, you know, see what's actually available. You know, we also believe that by doing this, this is where, you know, we've created these use cases and different findings that can come back. this is where, you know, I can have a AI model that might be looking at imaging studies in advance, could have a particular observation and get this back in front of the radiologist. So I can say, you know, look at this particular slice. I believe this is a pneumothorax. It would come back. So we did this in one of the observations just to kind of show. So if I look at, I believe it's, we used, you know, the device when we brought over, if I look at the initial preliminary, I said the preliminary was I detected pneumothorax, and we used that a device did that. And then what happened is, you know, we said afterward that particular report went final, and the provider actually then agreed with that particular item. So again, we think that long term, by doing this, you know, creating these observations, it would be good for, you know, AI models to be able to get their findings into the radiologist workflow as we move along. This also, I think, you know, creating these observations in very specific points is something where we can, you know, go further with clinical care guidelines, so that, you know, if I'm talking about a very specific finding and I want this particular mass biopsied, when the order's created for my surgeon to go about performing that biopsy, you know, they can link directly to the image, have that image brought up directly with those, you know, with that arrow pointed on. And, you know, in surgery, I've called that image directly using RESTful services and overlaid that particular arrow. We know exactly what we were talking about. There was no gray area at all when we're talking about this. And I think that's the hope. You know, that's what we're trying to describe. And, you know, the extension felt like it's the only way to move forward with this. You know, obviously I could call the image itself, or I could call GSPS objects, or I could call secondary captures. I could call key images, things like that. But I could never actually tell you, look at, you know, there's a line from this pixel to this pixel on the image that I brought up, and that's the exact line that I'm talking about. And I think that's the difference when I'm trying to embed this through FHIR, and it kind of helps me be a little more specific than I can in the DICOM world.
So very good. I don't see any new questions coming in, but we do have a great group still on the line. So I'm sure there must be experts in here. We're just waiting for a good moment to step in.
So Brian, it's Elliot again.
Okay.
Just to remind me, you said it's in ballot right now with breast cancer reporting.
Yes.
That's an HL7 ballot.
Correct.
And that closes.
I unfortunately don't know the answer to that.
And is that a STU ballot or?
Yes, it's right here. Hang on.
Ballot for comment?
Yes.
First
It's a
STU.
first
Okay.
STU.
All right.
But again, trying to at least get it somewhere that we could get some visibility to it.
Yeah.
And this also kind of shows where it would fit and why we're doing it. You know, the entire point about this is, these are the kind of things we sometimes see today. And how do you get much more specific with it? And I think that really that's where we're, in a breast imaging, if I'm asking for compression of a certain mass, you want to make sure you're actually getting that, that particular item looked at. And this is why, the breast reporting was, easier to get it into. It kind of made sense at the time, but there's lots of use cases where this is, available. I look at a liver and I see, a bunch of lesions, or I look at, a chest exam and I'm pointing out a bunch of areas, which specific item do I want to be biopsying? You don't want to have to do that more than one time with a patient.
Right. And you're working through II and DICOM Working Group 20.
Correct.
On this. Do you know if it's been reviewed by Working Group 6?
No, it hasn't gone to Working Group 6 yet. I did initially present to Orders and Observations to kind of get, some feedback there. And that's where there's a little bit of a difference on whether we took this, I specified specifically study series and instance UIDs, or we made it part of the URL. Again, my feeling is, extending it out and specifically putting it under context, so that because the URL can change, I didn't want to be tied to that particular URL. Plus, someone had to actually parse the URL to find it. So if I were trying to look at anything that went with a particular study UID, I couldn't just look at study UID fields. I'd actually have to parse that particular field and know that that particular, this markup could exist there. So, there was, I guess, from the radiology side, those people feel like this seems to be better. I think, obviously I understand on the FHIR side, there's some reluctance to add things that are potentially duplicate.
I think you'll
so that's why
find
these both
there's-
exist here today.
Yeah, I have a concern about potential duplication between DICOM and FHIR on this, and getting out of sync. I don't know where that goes, but that's my initial reaction.
Right, and I think that's, some of the URL pieces, I'd rather not point to a specific URL, because then I don't know what the latest version is.
Right. Yeah.
Again, I'd love to continue to get feedback. You can use the current ballot to do that. Again, these particular items are posted on the SIM Hackathon server. And also, if you'd like to, I will continue through DICOM Working Group 20, which their calls are posted, and talking to the II group, once we get some time to come back to this particular extension, to move that forward. So joining those calls would be much appreciated for additional feedback, or you can just send me an email. I'd be more than happy to discuss this. But thanks everybody for attending. I really do appreciate it.
Thanks, Brian.
Thank you, Brian. And Brian, so the questions are still in the Q&A, so feel free